Question 13. James always parks in a 3-level parking station and he chooses the level randomly, but he always forgets where he parked and he has to search for his car, choosing which level to look on first randomly. Now, what is the probability his car is on the first level he searches? Well, this is one to not overthink. There's 3 levels and his car is only on one of them, so your basic probability formula says what's the number of favourable outcomes over what is the total number of outcomes. So there's one favourable outcome, there's only one level that has his car on it, and there's 3 to choose from. So the chance that he gets it right first time is 1 out of 3. Now the second question is trying to trick us a little bit. What is the probability he must search all 3 levels to find his car? Now you can answer this 2 ways. One is you can say, well, the chance of it being on the 3rd level that he looks for is actually exactly the same as the 1st level that he looked on. After all, if you think, what are the chances that if he decided, put it this way, tell the story a different way and say he's going towards the parking station, he's going to look for his car, and he says, I'm going to look on the 2nd level, and then the 1st level, and then the 3rd level. Once he's made that choice to go 2nd level and then 1st level, there's only one way he can choose the 3rd floor, and that's to pick the 3rd level. So effectively, if he chose the last level he was going to look at first, the chances would be exactly the same. And just by sheer logic there, you could write down 1/3. Now, it's a 1-mark question because they know that this is something that you can just come at logically. Now, if you're having trouble thinking that through, you could draw a tree diagram, and you could say, all right, for question 2, he either finds his car or he doesn't. Let's use find for F for find, D for doesn't find. Now, if he finds it, that's it, there's no more looking, so that tree ends there. If he doesn't find it, then he's got 2 more levels to look at, and he either finds it or he doesn't. Now, if he doesn't find it that 2nd time, the next time after that, he's definitely going to find it because there's only 1 left. So the chance of finding it or not finding it on the first one he looks, he's got a 1 in 3 chance of finding it, so a 2 in 3 chance that he won't find it. Once he's decided it's not on that 1st floor, there's 2 floors left, right? One of them has the car on it and one doesn't. So our chances here is 50-50, half and half. But once he's here and he hasn't found his car on that 2nd level, the chances of he will find it here, it's certainty. It's 1. It's definitely on that last floor. So if you want to know what is the chance that he has to follow this trail, well, how do you get here? 2/3 times 1/2 times 1. This is just half of 2/3. The answer to this is 1/3. So this is a perfectly acceptable way of figuring it out using logic and a tree diagram. You could also tell the story backwards and figure it out that way too. This way is quite nice because it really proves your answer. All right, the 3rd question. What is the probability that on every day for 5 days it is not on the level he searches first? Now, the advantage of the tree diagram we've already drawn in question 2 is that we could use the same diagram for question 3. So, I'm thinking here, we need him to not find it on the 1st level. Now, what is the chance that he won't find it on the 1st level? It's just this, isn't it? There's 2/3 of a chance that he won't find it on the 1st level that he looks in. And we don't even really need to consider what happens after that because the question doesn't say how many levels he did have to look on, whether it was on the 2nd level or the 3rd level. It just says that it's not on the level he searches first. So he has this situation happen to him 5 days in a row. What are the chances of that? Well, all we need to do is think he has this happen, and then the next day he has it happen again, and then again and again. The chances of it is each time of the 5 days is exactly the same. So he needs to do 2/3 times 2/3 times 2/3 times 2/3 times 2/3. And that's 2/3 to the power of 5, which when you put in your calculator, you will get 32 out of 243. That's the chances that that happens to him in that week.